I'm hearing more discussions, and as we've been touching on already this morning too, about how cybersecurity is increasingly seen as a critical component of an industrial risk assessment. Can you explain a bit more about how cybersecurity fits in with equipment safety as part of a risk assessment?
Yeah. So if there's a bad actor who wants to get into your facility, they might be able to find a way, right? It all comes down to how secure it really is. If they get all the way down to the PLC, it's easy to assume that someone someplace could have used a bad password for the safety system and a bad actor got a hold of that password. So if they're able to get in and they're able to get into the safety system, they can reprogram the safety system and the sky's the limit. They could do whatever they want with it, right? They could very easily cause a situation that causes personnel injury or death. By ensuring the machines compliant with both functional machine safety standards and cybersecurity standards, you can reduce this risk significantly. If only one or the other is followed, the risk that someone can get in there and do harm is certainly increased.
Okay. So, what steps or procedures are part of a cybersecurity risk assessment, and how does that dovetail with the standard equipment risk assessment steps, such as defining the limits of a machine's functions, identifying specific hazards, estimating and evaluating the risk associated with those hazards, and then, of course, determining if the risk has been reasonably reduced?
Yeah, they're actually incredibly similar, which makes it a very natural progression for safety engineers to understand it. So ISO 12100, that covers functional machine safety. ISA 62443, that covers cybersecurity assessments, and they all revolve around the same question. Do you know what your risks are and what level of risk are you willing to tolerate, right? So by determining the risk you're willing to tolerate, and then determining what the risk of this new machinery or existing machinery is step one in both cases. From there, you move on to how do you mitigate it, right? And this is where this starts becoming the tricks of the trade and the tools of the trade, right? How you mitigate it completely different for every single different machine, right? But from what the process looks like, it's do I have a hazard that's more risky than what I want? How do I mitigate it? And move forward through there. But the actual validation of these is where they start differing more. So in a cybersecurity system, it really comes down to what networks or what systems are on my network and doing intrusion detection to see how can I get in, can I get through uh, my protections. And it's kind of the same as the functional safety too, right? I put systems in place and processes in place. How do I break it, right? You want to prove that they work, right? So trying to remotely access a system and prove that I can't do it is the same as pressing my e-stop and proving that the e-stop did the task, right? So the process you go through is similar in the original steps, but as far as the people who are doing it and the expertise, typically you're going to need a different team on one side versus the other.